All right, can everyone see my screen?
Yes.
Yep, I sure can.
All right, okay. Hello, everyone. I'm Sammy, and this is my presentation for my final project for the DE program. So first of all, real quick, I'll go through the thought process of doing this project. So first, I wanted to get Edwin's pipeline running as soon as possible so that I could have time, to try new things. And luckily, I was able to do that. I had almost 2 weeks since I got the pipeline running. So my next priority was to use a source of data other than the bus data that was of real interest to me. And the main reason for that is because in the midterm, I was using the banking data that was given to us, and I thought it was compared to other people who were doing really interesting stuff, it was my banking was a bit boring, especially people who did stuff about video games, because I am really into video games. So I wanted to do something very interesting like that. And of course, after that, I had to adapt the pipeline to that new source of data. And then if I had that working, I would add new features if I have time. So this here is Dyson Sphere Program. That's the source of data I chose to grab. This is a video game that has been released by a small Chinese developer studio. It's just 5 developers, I believe. It's still in early access, which is like kind of an open beta test, but paid one. And as I talk about the game, let me show you a 1-minute trailer. I'll talk over the trailer just to describe what's happening with the game. So basically, this is a game about resource management collection. It's a new genre of game they call factory building game. So you start with nothing. You collect very basic resources just to fuel your mech or your robot, and then you start collecting raw resources. Like here, there's iron ore being collected. So you start automating stuff that you do manually. You transport resources with like conveyor belts. You can store them, and then you start processing them. So for example, iron ore gets smelted into iron ingots, and then smelted into steel, and then complex products. And as you can see here, you build massive factories, and not just across like one planet, but actually multiple planets, multiple solar systems in the they call it the star cluster of the galaxy. And the end goal is to launch solar sails, or as they call them, solar sails, into orbit and build those Dyson spheres, as the game suggests. Dyson spheres are basically gigantic structures around stars that harness their energies, right? So the scale gets big pretty quickly. So the second reason I chose this, not just because I really love the game, and I myself, like while playing it, used to do like spreadsheets while playing it to track my consumption and production and logistics and resources, but also it kind of resembles a real life supply chain operation, I would say, even if it's a simple one, because there's a lot of production and consumption data going on, logistics and things like that. So for the scope of the project, I wanted to have the game running, extract a streaming data from the game as it is running, and process it through Edwin's pipeline, and then represent it as a graphical data in the end for analysis. So here's the pipeline. Now, most of it, like starting here, this is Edwin's pipeline. Basically, very little has changed, but this part here is mine. So basically, while the game is running, I wrote, I took one of the mods that were already present for the game and heavily edited for the purposes of this project. So this mod, written in C# extracts game data in JSON format and uploads it to S3 bucket. And that gets updated every 30 seconds. I found that to be kind of an optimal frequency because the game, like I don't want to use a lot of resources so that the game doesn't crash, right? So, and then Fast API is an application that will read the JSON file and output its data to an HTTP URL. And the reason I wanted to do that is so I can have a very similar entry point to the bus data into NiFi so that I didn't have to change a lot in the pipeline, right? And then the rest of the pipeline, I'm sure you're all familiar with. But very quickly, NiFi just reads the data from the URL, transforms it into MySQL, stores it into transform it into SQL format, stores it into MySQL running on EC2, and then Debezium connects that to MSK Kafka, and then a Scala code spins up Spark streaming to do ETL, to transform it into Parquet with Hoodie to attach metadata. And then the Parquet file is put on S3, and then Amazon Glue basically started by Hoodie integrates the data into a database, and then Athena is connected to Superset to run queries so that the Superset can show us a graphical representation of the data. So I have to say that developing the mod for the game in C# took the bulk of the time and effort for this project. And the reason is I had to learn a lot from scratch. So I am pretty new to coding. Like this program is my first real foray into coding, right? And I mainly learned Python. I didn't even go heavy into Scala. So C# was really, really difficult for me. So it took me a lot of time to learn it in 2 weeks. And of course, Visual Studio community, I had to learn that to be able to run C# effectively. And then, I needed to learn how mods worked in games and this particular game code, how it worked, because the mod integrates with the game code itself. So that took the bulk of my time and effort. So the features added, just as mentioned earlier, the mod took the bulk of the time, and fast API to grab the data, and some custom Docker images. So now let's go to the live demo. So I have the game running here, right? So this here is a debugger, or let's say a logger that's attached to the game that extracts, that basically shows me stuff. So I programmed my C# mod to output the data here as well as to the S3 bucket. So if we go to the S3 bucket and do a refresh, this is the JSON file that's having all the data. We can see that the date is the time is just now, right? So it's pretty updated. Every 30 seconds, this file is updated. And then Fast API is running on the EC2. So this is just the EC2 IP with the port for Fast API. We can see that the data is being grabbed here. And then from here, of course, NiFi grabs the data from the HTTP, transforms it into SQL, and then puts it to a MySQL table. And here we can see the MySQL table. I'll show you the schema if you want to see that, because everyone asked about that in Nasser's Discord SP. So basically, we're extracting product names, planet names, and star names for the star system. Then production actual, consumption actual, production theoretical, consumption theoretical. I'll talk about this later when we see the graphical representation for the data. How many buildings are producing, consuming, and this is game time elapsed to track how much time has passed since the game has started, and a unique game identifier to identify each game basically by the number that has been given for the random generation for the star cluster. Event time to use as a pre-combined key, and this is a combine of product, planet, and elapsed time to use as the main key. So if we do a count here, we should see that the number has increased from this to this, right? So that means we're getting data. And if we look here at the Kafka streaming, I already have everything started, so we don't waste a lot of time on that. There's so much to present in so little time. We can also see Spark streaming running on EMR, which takes us to the output S3 bucket. If we look here, we'll see that the last partition is also updated just now. And if we run a query on Athena on the game time elapsed to make sure, because this number always moves forward when the streaming, so it just changed, which takes us to the final part, which is superset. So I've prepared a simple bar chart here to represent the important data. So each entry here is a product, and this is a representation of the summation of all the production and consumption data for all the products across all planets, right? So we have first production actual and production and consumption actual, and then production and consumption theoretical. So basically the actual data is for what is happening right now. So only if the buildings are running, basically the facilities are running, then it will give us these information here. And the reason why the theoretical data is usually much higher, because not all facilities are running at the same time. Sometimes there's not enough power to run them all. Sometimes there's backlog because it's the production has been full, like it has filled the storage and there's no need to run the facility anymore, or there's not enough resources to run. But here the theoretical data is the maximum capacity if everything is running at full capacity, which is very like when playing the game, this can be useful to know, okay, like I just want to build enough buildings, enough facilities to make sure I fulfill my needs, and then I will troubleshoot and see if the buildings are running or not, right? So for the live demo, I'll draw your attention to the iron ore and iron ingots. So right now, iron ore production is a bit higher, so we're producing a bit more than we're consuming, which is good. But the iron ingots, which are a direct product of smelting the iron ore, we're a bit deficient in it, and this is kind of an important resource. Yes, we're actually producing a bit more, but I want to make sure that the capacity is enough to produce more in general if everything is running at full capacity. So let's go to the game real quick and do something about that. So we'll fly from our home planet here to our smelting planet, and this here is the Dyson Sphere that I talked about. This is basically a gigantic structure that is harnessing the energy from the star. And I'll show you real quick the scale. Like this is just one solar system, star system, right? And this is the entire galaxy that you can play in. And basically right now you can see like these little dots are transport ships that are transporting resources across star systems. So you can see the scale of this and how it can get really, really big, and the need for analysis on the data. So now we'll just warp real quick to our smelting planet here, and you'll see it's red because I color coded it with colored concretes. So red is for smelting. So this is my smelting planet where I do all the smelting. So so this is kind of late in the game. So we have something called blueprints that we can use to just stamp down basically pre-configured combinations of buildings. And what I'm doing now is just telling the game that, hey, I want to stamp down these buildings, right? So my little drones, construction drones, will just go out and start constructing buildings. So the big towers are logistics stations that we can put ships in them, and they will, so we can demand, so we're demanding iron ore and we're taking in iron ingots, right? And we have to get warpers first to let the ships travel across star systems. So the iron ore will come over here, will be smelted, and will go back with conveyor belts to the iron ingots to be transported where it is needed. So even though the buildings are still not operational, we should see a change soon in the theoretical values here. So in a little bit, so make note of the green value here. It's 54.1. That's how much iron ingots we're producing right now theoretically. And the consumption of iron ore, that's 82.1K right now. So yeah, so we will see that it slowly the production of iron ingots So this is refreshed every 30 seconds, and the pipeline takes a little bit to process the data, of course, with all the steps. But with every refresh, we should start seeing a change. So iron ingots production will increase, and also the consumption for iron ore will increase as more buildings are being built. I'll just one more refresh here. So more and more this is happening. And yeah, this tells us that the pipeline is working and that this is capturing data in real time. If we have more time, I'd show you more, maybe after the rest of the presentation. I know I'm already running a bit long, but just my final slides here. Basically, this is what I learned and improved that. Of course, C# and other components, Fast API I never used before, and I never made a game mod before, so I had to write code that modified the game code. The features I wanted to use AKS, but I didn't have enough time for that. Most of the time was dedicated to building the mod and making sure the rest of the pipeline worked, and other features I would add with time. Here are my public source code repos, so anyone is invited to look at them. They're public, and these are my Docker Hub images also. And I have to give special thanks first to the modding community for the game. They've been really helpful, and they helped me build that mod and understand and even set up my C# environment and everything. So they helped a lot. And of course, Stan and Jeng and Nat. Stan and Jeng helped me a lot troubleshoot my pipeline and build it, and especially Stan helped me with setting up Fast API. And Nat advised me on the architecture of the project. And of course, Edwin, taught me everything I know almost with data engineering. And since this is the theoretically the last day of the course, at least for part-timers, I want to thank my colleagues and everyone who helped me and everyone who's involved in this program. And real quick, if we go back here, so yeah, you'll see that there's a big difference now in the data, right? There's production of iron ingots is a lot bigger now, 91, right, theoretically. But iron ore, you can say it's just shifted because it's the biggest value now. It wants to consume a lot more. So now we know, we want to go back and maybe mine more iron ore to balance this out, right? But yeah, this is the end of my presentation. Sorry for running a bit long. And yeah, if anyone has any questions.
Wow. I mean, like great idea, great project, fantastic completion. I mean, like, congratulations. I think this is, I think it made it probably to the top 3 project. It's very competitive for Stan's completion.
Very kind of you. Thank you very much.
Seriously, I mean, from 0 programming skills and all the way where you are right now, man, I'm so proud of you. Proud of what you have been accomplished. Great job. Yes, Dan, do you wanna say something?
Yeah, Sammy, amazing projects. I'm really glad to see this project coming along. Great presentation. Yeah, good job. I'm really proud of you as well. Awesome.
Couldn't do it without you guys. Thank you very much.
Yeah, I mean,
Good
like,
job,
we really want to invite you for like more of like, how did you get up to speed on all the skill sets you have been acquired so far. I mean, like, great job. Any other questions from the rest of the folks?
Good job, Sammy. It's great to see you have a high quality presentations and the project. Yeah, really happy for you.
Thanks a lot.
Thanks, just a comment. Instead of like looking for an API, you built your own API. That's pretty cool.
Thank you.